A reverse proxy is a server that sits in front of other web servers and forwards requests to underlying web servers. Based on the complexity of your application, especially if you're doing a microservices application, you might have several web servers or containers. So the reverse proxy is one entry point that will distribute requests to ensure efficient use of resources and improve performance accordingly. So some of the key benefits of using a reverse proxy include the ability to load balance, so you can distribute the request load across several instances of any one service as needed. You can also do your SSL encryption at that level or that layer, so you don't have to do it for every single service that it is distributing traffic to. You can also put in things like caching and compression to improve the overall delivery speed of content. So for this activity, setting up the reverse proxy, we're going to use nginx. Now let's get started with setting up Docker. Go to docker.com and download the appropriate Docker client for your machine. Install it based on your particular machine. Once it has been installed, you will be led to install the Windows Subsystem for Linux. Subsystem, Google, Windows, WSL, you'll see this documentation. You can follow, go ahead and run this using your command prompt as administrator, and it will download and install that for you. Now, once you have Docker and the Windows Subsystem for Linux installed, then you can launch your Docker desktop. If it's the first time that you're running Docker, then you're not going to have any containers in this list. Let's talk a little bit about nginx. It is a free and open source web server that can also be used as a reverse proxy server, a load balancer, a mail proxy, and an HTTP cache. So it's a very versatile open source tool. It provides HTTPS server capabilities and is mainly designed for maximum performance and stability. You can read up a bit more from that URL that's there. And this article talks about how nginx can help when we're using it with Docker and Docker containers. So when we're thinking about the architecture when requests are being routed through a reverse proxy, it will look something like this. The client sends the request goes to the nginx reverse proxy, and that will forward the requests to the app or to the API server accordingly. So we want to set up an nginx container and then configure it to be the entry point to our underlying services. So let's get started on that. We're going to set up an nginx container, a reverse proxy that sits in front of our MVC and API container apps. So let's get started by creating a new folder in the same destination as the solution file, and we're calling it nginx. I already have the configuration file and the Docker files created, and you can go ahead and retrieve those files from the project resources, but I am going to go through the files line by line. So don't worry about that just yet. Once you have created the folder in the file explorer, right click the solution file again, and this time add a solution folder. Give the same name as the nginx folder. Since I already have the files, I'm going to add the items from the nginx folder, the Dockerfile and the configuration files. Let's take a look at the Dockerfile. We're getting the nginx latest image, and then we're going to remove the default config file from that image. Then we're going to copy over the nginx.conf file that we have right here in the same directory. And then I'm going to make a new directory where I'm going to create two files. One that is an access log and another one that is an error log. Then I'm going to expose a port. If you already have a server running on your machine, then you're probably already using port 80. I'm going to use 8083, which is a free port on my machine. Finally, we run a command to start the container. Now, nginx runs off a configuration file, and this configuration file will define how it should handle the web requests. This file is a bit complicated, and we still have to make some mods, so it's good to just go through line by line once again. So we're defining a worker process, worker connections that are allowed, and then we have this whole body called HTTP. Inside of HTTP, we have include MIME types, and we're allowing it to send some files. Then we're defining what the log format should look like. We're just defining the log format, and then I'm saying the access log should log to our access.log file, and our error logs should go to the error.log file. I have to make a modification here. So we have two server definitions, one for the API, one for the MVC application. For the API, I am here saying that I want to listen on port 80. Change the port here to 8083. The server name would be whatever address I want to allow a user to type in order to reach to that application. So if somebody types in api.conferenceattendees.com, then they should be routed to that application, which is our conferenceattendees.api. And this is the HTTP address that corresponds with our service name in the Docker Compose. See how that works? It all comes back to the Docker Compose container names. So I'm routing to the Docker Compose applications and of course the port 7106, since I'm forcing that port on the container during the orchestration. So you have these other options, which are pretty standard. You can just go ahead and copy them, but those are for forwarding headers from the proxy server. Then we move on to another server definition, which looks very similar. The only difference here is that I'm changing the server name to conferenceattendees.com, and the proxy pass value is going to the conferenceattendees.ui with the port. Once again, that is defined right here, and I have an error. So see, it's good that we reviewed it together. It should not be UI, it should be .mvc. Otherwise, I would have gotten an error when nginx would be starting up, the port would be wrong, etc. So you want to make sure that you are accurately transcribing that. Inside of the program.cs for the API project, I'm going to go to where we register our middlewares, and after HTTPS redirection, I'm going to go and say app.use forward headers, and we're initializing that with a new forward headers options object, and we're saying forwarded headers is equal to, and we use the enum forwarded headers dot x forwarded for and x forwarded proto. So these values are, this configuration will make sure that it can accept the information that is being sent over by our reverse proxy. So if we do that for the API, then we have to make sure that we do that for our MVC application as well. The final thing is to let Docker Compose know that when it is spinning up its services, it needs to also spin up the nginx. Add the new section and another section that we haven't seen before. But let us go through what we're doing to build the nginx container. We're setting the build to be the root context or the root directory for the context. And then the Dockerfile is in the directory nginx/Dockerfile. Because we put the Dockerfile inside of a folder, we have to make sure we have that file path. We're defining the ports 8083, so we're forwarding the traffic coming in from 8083 onto the port 8083 for the container. It depends on MVC because the order of things is that we want the seek and SQL containers to start up first. Then we want to start up the MVC, which depends on those two. And then the API depends on MVC. So don't start accepting any traffic here until the MVC, which is the last application container, is up. The new section is the networks. I'm stating that we have this network and we're setting up an internal network bridge between our containers. We want the nginx to be able to orchestrate all the internal traffic. I now need to add the other containers to the same network. Add the same networks section to the other services being defined in this file. So now we have set up our nginx container as a service. We just finished setting up our nginx configuration. Now we want to set up the local environment such that our routing or our URLs actually work. So we need to modify our internal hosts file. Now if you're on a Windows computer, this hosts file is located in C Windows System 32 drivers /etc. To modify this file, open it in admin mode. add the mapping references for the addresses that you just defined in your nginx.conf file. So 127.0.0.1 renders to localhost, which is why localhost with a port number works generally. So we're saying that anytime you see this address, then equate it to that localhost address. Then you save the file. So let us do a Docker compose. And I hit an error. It is saying that it could not find the conf file. And that is probably because I need to specify the directory here. So I need to say nginx/nginx.conf. So let me try that again. I see that all containers are running and we have a new container for the nginx. And if I click on that and view the logs, we get to see the server activity. I'm going to conferenceattendees.com with the port 8083. Notice that I got the application, and two, the logs went crazy, showing that the traffic is actually going through nginx to load up and do all the gets and every bit of web traffic that just allowed me to view this page went through our nginx. The next thing that we need to do is explore putting an SSL certificate on our services. We want to generate an SSL certificate per server or service that we know that we want our reverse proxy to be able to communicate with. So generate an API cert conf file, and I already did it. Here's the URL to the gist. So run through the file to see what it is doing. And I'll focus more on the more important parts, that if you were to take this and adapt it for your own purpose, the things that you probably want to change. You'd want to change this section or some of the details to match your own country, state, locality, organization, and whether it's development or not. You'd also want to change the common name based on your application needs. Finally, you'd want to change that DNS value to match whatever you put here as the common names. Back in Visual Studio, I created a file in the file system and then I added it to Visual Studio. The next thing we want to do is jump into our terminal and run a command that allows us to generate the key file for this configuration. If you're on Windows, you need the Windows subsystem. For Linux, you run that --install -d and choose the distro. I ran this command using the Ubuntu distro, and that allows me to access a Ubuntu terminal right here on my Windows computer. Navigate to the area where our project is, go into the nginx folder there, and there are our files. I need to run a command that's going to generate a certificate based on the contents of that configuration file. Our command is sudo open SSL req-x509 -nodes -days, and here I'm setting up that I want 365 days worth of validity for this open SSL cert that I'm about to generate. Then I'm going to say that I want a new key based on the RSA 2048-bit encryption. After that, I'll say -key out, which means what do I want to output this key and call it. So I'm going to call it api-cert.key. And after that, I'll say out, and then I'll use the same name, api-cert, but this time the extension is CRT, so we're generating the key and the certificate, and then the -config will take the name of the configuration file that we're using, which is api-cert.conf. And then finally, we'll set a password. Then they'll ask for the password for root. I have an error here. I need to say hyphen, then the certificate name, -config api-cert.conf, and -pass in. There we go. You're about to be asked to enter some information. I'll just press enter, press enter, press enter. And then ultimately we'll stop prompting me. These are just confirming the values that were already in the configuration file. If we do another dir on this same directory, what you're going to notice is that we now have a key file and a certificate file. Now we've generated our SSL cert files for our API website.
So now export a PFX file. I'm going to say sudo open SSL pkcs12-export-out and specify whatever the output file needs to be. In this case, I'm going to say api-cert.pfx. We're generating this PFX file based on the key files that we just generated. So in key is going to be api-cert.key, and -in is going to be based on api-cert.crt. We have to put in our password, and this time we're putting in the password that we just used to generate the files. So I have the same password, and I'm going to verify that password again. Now, if I check the directory, we're going to see that we have a new file once more, the PFX file. I need to actually install this PFX file on the host machine. Using Windows, just right click that PFX file and say install PFX, which brings up certificate import wizard. I'll just say local machine, so it's global to all the users on the machine. Go through some security checkpoints, ensure that the file path to the appropriate file that's accurate. Good, hit next. Then I'm going to use the same password that we've been using for our key creation activities. Hit next and place this inside of the trusted root certification authority. So this means the machine will trust it above a personal cert. Hit next one more time and finish, and we get a message: import was successful. So now our cert has been created and imported successfully. The certs we just created just so that we can see them inside of Visual Studio. Now we need to tell our Dockerfile for our nginx that it needs to also copy these additional files. So duplicate this copy line. I want to copy the api-cert.key file. And while I'm here, I'll just do the same thing for the api-cert.crt. And then we're copying into the etc or etc or etc /SSL /certs/ and then the name of the file would be the appropriate file that we're copying here. Actually, this is an error. The key file goes into SSL/private. So let me duplicate that line now and do the same thing for the CRT, but the CRT goes into the certs folder in etc SSL certs, and this is the CRT file. Now, the Dockerfile knows once it's building this container, it needs to also copy these two files into the appropriate folders for the SSL certs. Now we can jump over to the configuration file and make the following adjustments. Replace this entire listen 8083 with this section. So I'm listening now on port 443 with the SSL flag. And then I have two lines, SSL certificate and SSL certificate _key. The SSL certificate is going to use the same path that we just defined in the Dockerfile for the nginx container, in the line with a semicolon, and it's the same file path to the key file. The next adjustment is to this host section. Set up a port here, say 44391 and 44391, just in case there is anything else competing with 443. At least when this is redirected, it knows that it should go to 44391. In our Docker compose.yaml file, modify the port forwarding for our nginx. I want to accept traffic from 44391 and forward it to 443, which is what the server itself is listing on. Now, rebuild or clean the solution. When you do a clean, it will destroy all of the containers that might have been created from the last Docker Compose, and then run Docker Compose again. When everything is loaded, we are still getting our API loading at DP localhost with the port. But let us try and get to the API through our HTTPS address. Type https:// our DNS name, which is api.conferenceattendees.com, and that forwarding port 44391 as we put in the config, and try to get to the same Swagger doc. Now we are loading up our website and the connection is secure.
through our SSL cert. We have successfully configured SSL termination for at least one of our services. My challenge to you is review the steps that we just took to do it for the API project and try and replicate that on the MVC project. In the next lesson, we can complete those steps.